Johnson's Shut-ins is one of Missouri's premier swimming holes. Water cascades through billion-year-old rocks, creating chutes, pools, and waterfalls. It's a great summer getaway that's not far away.
One of everybody in Missouri's favorite places to go and recreate.
And it's not too far for Claire Masteller to study.
It's called a shut-in because where that hard resistant bedrock meets the surface, the river has to get really narrow and really steep and create these rapid formations to sort of plow through that solid rock. So we're really interested in that location because in that place it's a bedrock river, it's really energetic.
Masteller is an assistant professor of Earth and Planetary Sciences at Washington University in St. Louis.
We're interested there in understanding how those beautiful bedrock features erode and change through time. We're trying to link the different flood characteristics to what the river looks like. That work has really been led by an undergraduate researcher in my lab, Jordan Neely, and now we've started to pull in a bunch of other people from all around WashU.
H-top dash.
At Johnson's Shut-ins, they are studying flooding and bedrock river erosion. Masteller is also studying shifting rivers and changing landscapes from flooding and erosion that happens with climate change.
But that's where the experiments really come in handy, right? Because we don't have to wait around for climate change to happen.
The research team is using different tools like this flume so they can conduct experiments without risking their safety when actual flooding occurs.
We really care about when this stuff starts to move. When the gravel starts to move, you're doing the work of erosion that's changing a landscape.
In this case, the experiment is for a gravel bed river. The contents of the flume change for Johnson's Shut-ins experiments.
Instead of filling it with gravel, we can put bedrock blocks in it, and we can then have gravel bounce on top of the bedrock, and we can measure how that bedrock erodes.
Other technologies are deployed on site.
Seismometers down there that can feel the vibrations of the water as it flows through the river, so we can really get a high-resolution record of all the flooding and the erosion there. And what that allows us to do is avoid the dangerous aspects of trying to get into a river while it's flooding. We can record those vibrations of, say, that rushing water or the grains of sediment bouncing against the rock, and we can use that record instead to interrogate what's really happening during a flood.
The seismometers are strategically placed, and the data is routinely retrieved for analysis.
We have 3 different ones placed in 3 very different parts of Johnson's Shut-ins. We like to get as close to the river as possible without being in the flood zone, so I think they're about 30 feet away in 2 of the cases, and then where our rapids are, we have them a little bit further away just because of access. We actually go down and we'll do every month or 2 and download our data and then look at how the topography changes.
And they're using geospatial technologies, gathering topographic data generated by a LiDAR drone.
Go out and use unmanned aerial vehicles, UAVs, to take laser scans of the river before and after these floods and try and get a sense of how they're changing.
So that's the river bed, and then as we zoom out, we get the sides of the river and the trees and all that stuff. But then we can make certain different types of measurements from this.
The topographic scans, combined with repeat photos and seismic wave velocity measurements, allow researchers to measure the effects of different erosive processes at Johnson's Shut-ins. And as the work continues, the flume is proving to be a valuable asset too.
We like to go and find places where we can go out and take measurements, but sometimes during a flood event, it's actually really dangerous. And so we like to pair these experiments that we can really tune to look at floods of very specific sizes or different types of events, and then figure out how do we link that to what we see in reality when we go out into the field to a place like Johnson's Shut-ins or other rivers around Missouri.